Welcome back, everyone. Ready to dive back into the AZ-104 exam prep?
Absolutely. We're picking up where we left off, diving into Azure Compute, the heart and soul of so many cloud solutions.
Right, because knowing Azure Active Directory and how subscriptions work is great, but this is where the real action is, right? Like
Mhm.
actually building the stuff that runs in Azure.
You got it. This section of the exam is all about deploying and managing Azure Compute resources, VMs, containers, web apps, the whole works. And the exam really digs deep, so buckle up.
Okay, so not just click here to launch a VM, but
Yeah.
like really understanding the why and when behind the choices.
Exactly. Let's start with virtual machines, or VMs, probably the most fundamental compute resource in Azure.
Makes sense to start there. It's where a lot of folks begin their cloud journey.
For sure. But even if you've launched a zillion VMs before, the AZ-104 might throw you a curveball.
Oh, I bet. Like
Mhm.
what kind of VM questions could trip someone up?
Well, think about availability. The exam loves to test if you really understand the difference between availability sets and availability zones.
Yeah, those trip me up at first. It's easy to think, I'll just put everything in a zone and be done with it.
Right. But zones come with a cost premium. So the exam might ask, which is the most cost-effective solution for a given scenario?
Okay, so it's about trade-offs, not just knowing the definitions.
Absolutely. Availability sets are great for protecting against hardware failures within a data center.
Right, so if one server goes down, your app keeps running because it's spread across multiple servers in that data center.
You got it. But availability zones, those are about protecting against an entire data center going offline.
So, like, if a meteor hits the data center, your app survives because it's running in a different zone which is physically separate.
Exactly. Each zone has its own power, cooling, network, the works. But that redundancy comes at a price.
Got it. So if you have a mission-critical app that absolutely cannot go down, zones are your friend, but you better be ready to justify that extra cost.
Exactly. Weighing risks and costs, classic IT decision making, even in the cloud. And speaking of making smart choices, don't forget about storage.
Oh yeah, the exam loves to quiz you on all those different disk types, HDD, SSD, standard SSD. It's like a menu, and I always forget what each one is good for.
Think of it like this. HDDs are your budget option, good for bulk storage or things that don't need to be super fast.
Okay, so like archives or backups.
Exactly. Then you have SSDs. Those are the Ferraris of storage. Perfect for databases or applications that need super fast read and write speeds.
Makes sense. So when would I use this standard SSD thing? Is it just a compromise between the two?
You got it. Standard SSDs offer a good balance of performance and cost. If HDD is too slow and SSD is overkill, standard SSD might be your sweet spot.
So for the exam, I need to be able to recommend the right storage type for a given scenario.
Exactly. You need to understand the workloads and pick the most cost-effective solution.
Makes sense. Now, another big part of deploying VMs is choosing your operating system, and Azure supports both Windows and Linux.
Right, and the exam expects you to be comfortable with both.
So no escaping learning Linux if you're a Windows person like me.
I hate to break it to you, but that's the reality of Azure administration these days. You've got to know both worlds.
All right, fair enough. So when it comes to actually deploying these VMs, are there any major differences between Windows and Linux that could trip us up on the exam, or is the basic process pretty much the same?
Good news, the core steps are very similar. You choose your VM size, storage, networking, all that jazz. It's more about understanding the nuances.
Okay, so what kind of gotchas should we watch out for?
One that gets people is diagnostics. See, whether it's Windows or Linux, those diagnostic settings are crucial for troubleshooting.
So it's not just about spinning up the VM, but knowing how to actually monitor it and figure out what's wrong if something goes sideways.
Exactly. And speaking of things that can go wrong, let's talk about the temporary disk. That little guy can be a real trap on the exam.
The temporary disk, that's just the local storage on the VM, right?
Oh.
Honestly, I haven't given it that much thought.
That's where a lot of folks get caught. It's called temporary for a reason anything stored there is gone if the VM reboots or gets redeployed.
Wait, seriously. So if I'm troubleshooting and reboot the VM, any log files or data I saved on the temporary disk could just disappear.
Poof, gone. That's why it's critical to store important data on persistent storage options if you want to keep it around.
Okay, that's a good one to remember. I'm definitely making a note of that.
Yeah.
Are there any other common VM gotchas the exam might throw our way?
Another classic is dynamic IP addresses. You see, when you redeploy a VM in Azure, it might move to a different physical server, and when that
I
happens,
think it's a new IP address. So if I was relying on that IP address for anything important,
things could break. Exactly. If you need a permanent IP address, always make sure to assign a static IP to your VM.
So many things to consider. I'm starting to see how this exam really tests your real-world knowledge, not just book smarts.
Exactly. It's about applying those concepts to solve real problems. Now let's talk about scaling, because building a single VM is one thing, but what happens when you need to scale your applications to handle massive workloads?
That's where Azure scale sets come in. I've heard they're like having an army of VMs at your disposal.
You got it. Imagine your website suddenly gets slammed with traffic. With scale sets, you can automatically spin up additional VMs to handle the load.
Okay, that sounds amazing. But are scale sets difficult to set up and manage?
They can be a bit tricky, which is why the AZ-104 exam loves to ask about them. Be prepared for questions about how scale sets work with load balancers to distribute traffic, how updates are rolled out to minimize downtime. It's a whole other level of Azure mastery.
Sounds like I need to brush up on my scale set knowledge. But before we dive into that rabbit hole, can we touch on security for a moment? We've talked about some aspects already, like static IP addresses, but what about protecting the data on our VMs?
Great point. Azure disk encryption is crucial, and the exam will definitely test you on it.
Okay, disk encryption. I know that's important, but refresh my memory. How does it actually work in Azure?
It uses BitLocker technology to encrypt the data on your VMs. So even if someone swipes your disks, they can't access the data without the encryption keys.
So like having Fort Knox level security for your data, even in the cloud.
You got it. And the exam might ask about different aspects of disk encryption, how to enable it, manage those encryption keys, even how it impacts performance.
Okay, got it. Security, always top of mind.
Now let's wrap up this VM section with something I know you'll appreciate, ARM templates.
Ah, yes. ARM templates, every Azure admin's best friend. Or at least, that's what I keep hearing.
They should be your best friend.
Yeah.
ARM templates let you define your infrastructure as code, which means you can automate deployments, ensure consistency, and treat your infrastructure like software.
Okay, that sounds powerful, but also a little intimidating. How deep does the AZ-104 go into ARM templates?
They could give you a scenario and ask for the correct ARM template syntax to deploy a resource, or maybe ask you to troubleshoot an existing template.
So I can't just know what they are. I need to be able to read and understand them.
Precisely. The good news is Microsoft has a ton of documentation and examples for ARM templates, and there are great online tools to help you validate your templates and catch any errors.
That's reassuring. Okay, I'm putting master ARM templates on my to-do list.
So we've covered VMs, but Azure Compute is more than just VMs, right? What other exciting topics are we diving into today?
You're right. Next up, we're jumping into the world of containers. Are you ready to explore the magic of packaging and running applications in these lightweight, portable wonders?
Containers, they always seem so cool and efficient. I'm ready to go beyond the basics. Let's talk containers, right? Containers, they're like the trendy tech that everyone's talking about. But in plain English, what are they and why should someone prepping for the AZ-104 care?
Imagine you've baked this amazing app, but it only runs perfectly in your kitchen with your specific oven.
Okay.
Containers are like taking that app, putting it in a portable oven with all its ingredients and settings pre-configured, and now you can bake it anywhere with consistent results.
Okay, that's a delicious analogy.
Right.
So, containers package up the app and everything it needs to run, but how does that translate into benefits for an Azure user, especially thinking about the exam? Portability is huge. You can run the same container on your laptop, on-premises servers, or up in Azure without compatibility nightmares. The exam might ask about migrating an app from on-prem to Azure, and containers could be part of the solution.
Got it. Containers make moving things around smoother. But the study guide also gets into Azure container instances. Are those just containers running in Azure, or is there more to it?
You're on the right track. Azure container instances, or ACIs, are like the easy button for running containers in Azure.
Okay.
They're great for simple deployments, quick tests, or maybe running a batch job that doesn't need a whole lot of orchestration.
So if ACIs are the easy button, I'm guessing there's a more complex but also more powerful option. The exam wouldn't let us off that easy, would it?
You know it. When you start dealing with multiple containers that need to talk to each other, scale up and down dynamically, or handle complex deployments, that's where Kubernetes comes in.
Kubernetes. I knew we couldn't escape the container conversation without mentioning the K word. It's powerful, sure, but it's also kind of infamous for being a lot to wrap your head around.
It's true, Kubernetes has a learning curve, but the AZ-104 exam focuses on the core concepts you'll need.
Okay.
Think of Kubernetes as the conductor of your container orchestra. It makes sure all the different parts of your application running in their individual containers are playing together harmoniously.
Okay, that makes it a bit less intimidating. So if I'm studying for the exam, what specific parts of Kubernetes should I focus on?
Definitely understand pods, deployments, and services.
Okay.
Pods are like the smallest unit of deployment in Kubernetes. They hold one or more containers.
Okay.
Deployments manage the rollout and scaling of your pods.
Okay.
And services expose your application running on those pods to the outside world.
Got it. So pods hold containers,
Right.
deployments manage pods, and services connect those pods to users. It's like a container hierarchy.
You got it. And while we're talking about Kubernetes on Azure, you definitely need to know about Azure Kubernetes Service, or AKS.
AKS, another acronym. Is this Microsoft's way of making Kubernetes a little friendlier in Azure?
Exactly. AKS takes care of a lot of the heavy lifting of setting up and managing your Kubernetes cluster.
Nice.
That way, you can focus on deploying your awesome containerized applications.
Okay.
The exam might throw you questions about creating an AKS cluster, scaling it, or even upgrading the Kubernetes version it runs.
Sounds like AKS is a must-know for the AZ-104.
Definitely.
Now, before we move on, can we circle back to security? Containers seem great, but they also feel like could be a security minefield if you're not careful.
That's a really important point. The exam might ask about securing your containerized applications.
Okay.
Think about things like using private container registries to store your container images securely.
Right, because if someone gets access to your container image, they could potentially see your entire application code and even sneak in some malicious stuff, right?
Right. Exactly. Also, pay attention to container networking and how you isolate your container workloads from each other.
Mm-hmm.
And don't forget about role-based access control. You want to make sure that only authorized users and services can access your containerized applications.
So many layers to security. That's definitely not something to overlook, especially in the cloud.
For sure.
Okay, shifting gears a bit, the study guide also dives into web apps.
Mm-hmm.
I know Azure App Services is the platform for that,
Yeah.
but why would someone choose that over, say, just setting up a web server on a VM, which we already talked about?
You've hit on a key concept that the exam often tests choosing the right compute service for the job.
Right.
App Service is a platform as a service, or a pay-as offering.
Mhm.
It's all about taking away the underlying infrastructure headaches.
So less time worrying about server updates and security patches, more time building amazing web apps. I can get behind that.
Exactly. With App Service, you focus on your code, and Azure handles the rest.
We love it.
The exam might present you with a scenario. Let's say you need to deploy a simple website quickly and cost-effectively. You'd need to know that App Service is usually a better fit than setting up and managing your own VMs.
Makes sense. But even with an app service, I know there are different plan options. What's the deal with those, and why would someone choose one over another?
Great question. Think of app service plans like choosing your apartment building.
Right.
A shared plan is like a bustling complex. It's affordable, but you're sharing resources with other tenants, so your performance might vary.
Right.
A dedicated plan is like renting a whole floor. It's pricier, but gives you more control and predictable performance.
Okay, I'm starting to get the hang of this. Now, what about deploying web apps? Is it just a matter of uploading your code and calling it a day, or are there things I should be aware of, especially for the exam?
The exam might ask you about deployment slots, which are fantastic for testing new code or features without affecting your live website.
Wait, so it's like having a staging environment built right into app service? That's incredibly convenient.
Exactly. You can test your changes in a staging slot, and once you're happy, swap it with your production slot. It's a seamless way to push out updates.
That's brilliant. What else should I keep in mind about deploying and managing web apps for the AZ-104?
Be prepared to answer questions about configuring custom domains,
Mm-hmm.
scaling your web apps up or down based on demand,
Okay.
and implementing security features like authentication and authorization.
Okay, so it's not enough to just deploy the web app. I need to know how to secure it, scale it, and make it look professional with a custom domain. Got it. What else is on the menu for the Azure Compute portion of the exam?
Well, we've covered VMs, containers, and web apps, but there's still a crucial piece of the puzzle. Serverless computing. Have you ever worked with Azure Functions or Logic apps?
I've heard the terms thrown around, but honestly,
Sure.
a serverless always felt a bit mysterious. Like, how can you have computing without servers? It sounds like something out of a science fiction
Oh,
novel.
I know, right?
Oh,
Oh,
right.
but trust me, it's very real and incredibly powerful.
Right.
In a nutshell, serverless computing lets you run code without having to manage any infrastructure. You just write your code, deploy it, and Azure takes care of everything else.
Wow, that sounds incredibly liberating. No more provisioning servers, configuring operating systems, or worrying about patching, just pure coding bliss.
Right.
But how does it actually work? Okay, I'm wrapping my head around this serverless idea. It's like magic.
Yeah.
You just write the code, and it magically runs somewhere in Azure. But seriously, what's the secret sauce behind it?
It's all about abstraction. With serverless, you're not provisioning VMs or managing infrastructure.
Wow.
Instead, you're working with a higher level of abstraction, focusing on the code itself.
Okay.
Azure takes care of running that code in response to events or triggers.
Events and triggers, those sound important.
Yeah.
Can you give me an example? Like, how would I actually use serverless in a real-world scenario?
Sure. Let's say you want to build a system that automatically resizes images uploaded to a storage account.
Okay.
With Azure Functions, which is Microsoft's serverless compute platform, you could write a simple function that gets triggered whenever a new image is added to the storage account.
So the function just sits there patiently waiting for an image to appear, and then it springs into action, resizes the image, and goes back to sleep. That's amazing.
Exactly. And you only pay for the actual execution time of that function.
Okay.
If no images are uploaded, you don't pay anything. That's one of the huge benefits of serverless.
Right.
It can be incredibly cost-effective, especially for tasks that happen sporadically.
I can see how that would be a game changer for certain applications.
Yeah.
But the exam probably isn't just going to ask me to define serverless.
Yeah.
What kind of practical knowledge do I need to have?
The AZ-104 exam might ask you to differentiate between different serverless offerings like Azure Functions and Logic apps.
Okay.
Functions are great for running snippets of code,
Hmm.
while Logic apps excel at automating workflows and integrating with other Azure services.
So functions are for focused code executions,
Mhm.
and logic apps are for orchestrating larger processes. It's like choosing the right tool for the job, even within the serverless world.
Precisely. And speaking of tools, the exam might also test your knowledge of serverless tools and frameworks like Azure Functions Core Tools, which lets you develop and test functions locally.
Okay, so I should be prepared to answer questions about the tools I'd use to build, deploy, and debug serverless applications.
Yeah.
Anything else I should be aware of?
Security, as always, is paramount.
Of course.
Be prepared to answer questions about securing serverless applications, including managing access keys, protecting sensitive information, and implementing proper authentication and authorization.
Right, just because you're not managing servers doesn't mean you can ignore security best practices.
Got it. So we've covered a lot of ground here. VMs, containers, web apps, serverless. It feels like we've explored the entire spectrum of Azure compute. Is there anything else we need to touch on before we wrap up this section?
There is one more thing, and it's a big one, especially in the age of AI and machine learning, choosing the right compute service for your workload. Okay, so it's not enough to just know how to use these services. We also need to know when to use them. Like, how do I decide if my application should be running on VMs and containers
Yeah.
or as a serverless function? It's like trying to choose between a screwdriver, a hammer, and a wrench. They're all useful tools, but for different purposes.
You've hit the nail on the head, and that's precisely the kind of thinking the AZ-104 exam wants to assess.
Okay.
Can you analyze a scenario and determine the most appropriate compute service based on factors like cost, scalability, performance requirements, and security considerations?
That's a tall order.
Yeah.
Are there any tips you can share for making these decisions? Like, what are some red flags that might point me towards one service over another?
Absolutely. For instance, if you have an application that requires tight control over the operating system and underlying infrastructure,
Okay.
VMs might be the best fit.
Okay, so for maximum control and customization,
Yes.
VMs are the way to go.
Yeah.
What about containers? When would those be the preferred choice?
Containers are fantastic for applications that need to be portable, scalable, and easily deployed across different environments.
Mhm.
They're also a great choice for microservices-based architectures.
Right, it's all about that consistency and ease of deployment.
Yeah.
Now, what about serverless? What kind of scenarios scream serverless to you?
Serverless is perfect for event-driven applications, tasks that happen infrequently, or workloads that need to scale rapidly based on demand.
Okay.
If you have a function that only needs to run for a few seconds a day, it probably doesn't make sense to keep a VM running 24/7 for that.
That makes a lot of sense.
Yeah.
It's all about finding the right balance between cost, performance, and scalability. This has been incredibly helpful. I feel much more prepared to tackle those choose the right compute service questions on the exam now.
Excellent. And remember, there's no one-size-fits-all answer.
Right.
The best approach often involves a combination of different compute services working together.
So it's not just about picking one and sticking with it. It's about finding the right mix for your specific needs. That's a great takeaway.
Exactly. Azure's flexibility is one of its greatest strengths.
Well, I think we've thoroughly unpacked the Deploy and Manage Azure Compute Resources section of the AZ-104 exam. From VMs to containers to serverless, we've covered a lot of ground today.
We certainly have. And I hope our listeners feel more confident and prepared to tackle this challenging but rewarding exam.
Absolutely. Remember, this exam is about demonstrating your understanding of Azure Compute concepts, not just memorizing facts. So keep experimenting, keep learning, and most importantly, keep building awesome things in Azure.
Well said.
And on that note, we'll wrap up this episode of The Deep Dive. Until next time, happy Azuring.